Welcome to solverfy.
In this question, we're given the molar volume of chlorine at Cl2 at STP, which is equal to 22.06 liters per mole. And we're also given the molar volume of NH3, this is gas, Cl2 gas, at STP, which is equal to 22.40 liters per mole. So these numbers are quite close together, so given their different molecular weights, dipole moments, and molecular shapes, for part A, why are their molar volumes nearly the same? So the molar volume refers to the volume occupied by 1 mole of gas as 1 mole of all substances have the same number of particles in them. Also, the gas molecules do not exhibit much of the attractive forces among its particles. So under standard conditions, of temperature and pressure, one mole of the gases, of all the gases, occupy a similar volume. Therefore, the molar volume of Cl2 gas and NH3 gas are almost the same. For part B, on cooling to 160 Kelvin, both substances form crystalline solids. So do you expect the molar volumes to increase or decrease on cooling to 160 Kelvin? So on cooling the gases, to form crystalline solids, the intermolecular forces come into action as the molecules are now closer together. This results in a decreased molar volume of both gases upon cooling. For part C, we're given the densities of both gases at 160 Kelvin. Let's calculate their molar volumes. So the density would be equal to the molar mass times the molar volume. So this would be our molar mass. This would be our molar volume. So we'll look at Cl2 gas at 160 Kelvin, and we'll calculate its molar volume. We're given its density as 2.02 gram per centimeter cubed. And molar mass here is 71.0 grams per mole, and this would be our molar volume here. So our molar volume here is going to be equal to 143.42 centimeters cubed, mole per centimeters cubed. And we'll multiply this 1,000 centimeters cubed grams, and centimeters cubed. This would be, let me redo this here, 1.0 grams per mole over 2.02 grams per centimeters cubed times 1,000 centimeters cubed, equivalent to 1 liter. This would give us a molar volume of 0.0351 liters per mole. And that would be the molar volume of the Cl2 at 160 Kelvin. Let's calculate the molar volume of NH3 at 160 Kelvin. So using the same formula here, the molar mass is 17.0 grams per mole, and the density given is 0.84 grams per centimeters cubed, 1,000 centimeters cubed in 1 liter. This would give us 0.0202 liters per mole. So here's our molar volume of NH3 at 160 Kelvin. For part D, are the molar volumes in the solid state as similar as they are in the gaseous state? So the molar volumes in the solid state are different than that observed in the gaseous state, because of the significant values of intermolecular forces that come into action in the solid state. The presence of dispersion forces in Cl2 is much more prominent in the solid state than the gaseous state. Hydrogen bonding being stronger than dispersion forces results in a decreased molar volume for NH3. And for part E, would you expect the molar volumes in the liquid state to be closer to those in the solid or gaseous state? So in gases, the intermolecular forces are almost negligible, hence the volume occupied is very large. Volumes in the liquid state would be closer to that in the solid state, because in the liquid state the intermolecular forces of attraction are still significantly less are still significant though less than that of a solid.